California has long been known to be a fire-prone state, a trait that has been beneficial to keep the state's ecosystems in balance and intact. The long, dry Californian summers transform vegetation into the perfect fuel alongside the annual winds that sweep across the landscape. The benefits of wildfires are numerous, from regenerating tree stand variability to promoting species diversity. Historically, 1.5 million acres of land would burn each year. Then, from 1935 until 1999, because of fire suppression practices, that number decreased to 57,000 acres per year. However, in the decade from 2008 to 2017, 6.9 million acres of land has burned in wildfires, showing a dramatic increase in numbers and intensities of fires. So, what can we do within our communities and state to adapt to our changing fire patterns and to protect our ecosystems, homes, and human lives from the devastating effects of wildfires? Fires in California are common because of the coupling of a dry, warm Mediterranean climate and ignition by natural causes, most often lightning strike, or from Native Americans. Californian Native Americans have been igniting fires for 13,000 years, fires which were high frequency but low intensity. Research shows this practice actually helped maintain healthy forests. Understories were largely clear and open, trees were old, healthy, and spaced apart, and the forest floor was often grassy. However, despite the numerous benefits of fire, in 1935, the U.S. Forest Service mandated that all fires should be suppressed. This single act disrupted the natural Californian fire cycles and has effects we still feel today. In the 20th century, since fire suppression began, we have seen the changing of California's vegetation composition. Understories have become much more dense with foliage and low-lying plants, and forests have become more overgrown as a result of the lack of low-intensity fires. When there are large amounts of foliage, shrubs, and other plants covering the forest floor, fires can spread quickly and gain intensity. This growth serves as fuel for the fire. And because of decades of these fuels being built up on forest floors, fires we are seeing today are burning hotter and faster than before. This densely packed vegetation causes more dangerous fires. This, paired with increased human presence, only further exacerbates the problem of dangerous wildfires. In the United States, from 1992 to 2012, 84% of the 1.5 million wildfires reported were human-caused, with power line ignitions being the leading cause. Now, what can we expect for California fires looking forward when we consider a changing climate? Predictions and models point to California overall becoming a drier state because of climate change. Warmer, drier winters means earlier snowmelt and thus longer periods of dryness in warmer seasons. This means fire season starts earlier and extends longer than is historically expected. Currently, fire season is 75 days longer than it used to be. This also increases the risk of drought, which too can play a role in worsening wildfires as plants burn more readily. Not only does the dryness itself contribute to higher fire risk, dryness of trees makes forests more vulnerable to pests and pathogens, thus further decreasing the health of the forest and increasing fire risk. Almost half of the land in California, a cumulative 48 million acres, is classified at being at high or extreme fire risk. There is also a buildup of fuel from fire suppression practices in California over the past century. This will not only lead to more fires, but more intense fires. It is predicted that statewide fires may nearly triple by 2085. Changing fire patterns overall impacts biodiversity, watersheds, air quality, and habitats, as well as the economy and other sectors. Cal Fire spent more than $947 million on fire suppression during the 2017-2018 fiscal year. As climate change continues, these costs are expected to increase. More wildfires means potentially devastating loss for residents near these fires. From loss of property like homes and businesses to loss of life, the impacts of wildfires are great. California wildfires in 2018 killed more than 100 people, destroyed more than 22,000 buildings, and burned over 1.8 million acres of land, making it the worst fire year ever, a record trailed closely by 2017. It is clear that the wildfire risk situation is increasing dramatically every year, and that actionable solutions need to be made. One proposed adaptation strategy for wildfires in California is the use of forest thinning through mechanical thinning and prescribed burning. Historic fire-frequent forests were characterized by lower tree density, a higher proportion of pine species, and greater within-stand spatial variability when compared to contemporary forests. A study done by Eric Knapp determined that high variability thinning and prescribed burning best aligned with conditions in historically healthy forests that are more resilient to both wildfire and drought. This proposed solution would benefit not only community health, but community budgets as well. CAL FIRE, who currently has fewer engines, yet both longer fire seasons and more land to manage, proposed a budget increase of about an additional $84 million in 2020 and around $60 million for consecutive years for fire management. In comparison, mechanical thinning costs around $2,000 to $3,500 per acre, and prescribed burning costs $400 to $1,500 per acre. With an estimated 15 million acres of land in need of thinning, these overall costs would be much cheaper in the long run than the drastic increase of the CAL FIRE budget. Another proposed adaptation strategy is reforestation of oaks to promote ecological resilience. This increasing fire frequency and severity of fire and drought events have negatively impacted the capacity and success of reforestation efforts in many western U.S. forests. As we see large-scale fires completely decimating landscapes, it is also important to consider reforestation of more resilient tree species in low precipitation regions. Certain areas of California's forest will be challenging to mimic historic patterns. A solution is to help strategize for early fire and drought stress, while enhancing the ability of conifers to compete with other vegetation. As we can see in this digital landscaping model, climate-induced stress will create different areas of refuge for tree species based on water availability. Oaks have a broad ecological niche, so it would be beneficial to focus replanting methods of already native oak species into mature stands. These tree species are also fire-resistant, which would decrease the risks of large-scale fires while also maintaining diversity within local ecosystems. Modifying reforestation practices to promote lower density, structurally heterogeneous stands will have the primary ecological benefit of increasing fire resistance and/or resilience of forest stands as they develop and mature. Another complication of wildfires are power shutoffs in high fire risk regions. In 2019, 30 counties in both Northern and Southern California faced shutoffs in hopes of decreasing fire risks from power lines due to the combination of high autumn winds and dry conditions. The shutoffs affected around 3 million people with blackouts. Blackouts that occur can be severe, impacting critical infrastructure such as hospitals, wastewater treatment, and communication infrastructures. Establishing a microgrid may help mitigate this problem. A microgrid is a specifically designed segment of the electricity distribution grid's mesh that can either operate as part of the wider grid or as an independent island that serves some or all of the electricity users within its boundary, even when the wider grid fails. State agencies that have examined a microgrid's potential all seem to agree that microgrids can enhance resilience to extreme events such as fires and are well suited to do so for critical infrastructure facilities. It is crucial to base them on solar plus storage rather than fossil fuels, as diesel generators only have enough fuel to last a couple of days, whereas batteries can be replenished when the sun comes up. Strategy 3 for mitigating wildfires is to increase funding for the 2018 policy plan SB 901. It is clear that to tackle the problem that California wildfires pose, policy changes are needed. SB 901 was enacted to aid in forest health improvements and in reducing fuel loads throughout the state over the next 5 years. So far, roughly $1 billion has been generated for this plan under the Greenhouse Gas Reduction Fund from California's Cap-and-Trade program. Yet, while this is helpful, virtually no funds have gone towards upgrading state utility infrastructure. From 2014 to 2017, Pacific Gas and Electric of Northern California was the cause of over 1,500 fires from power lines. Expanding benefits under SB 901 will allow for upgrades of current structures such as high-voltage power lines, which should help decrease or potentially eliminate fires caused by electricity suppliers. Although strategies to help restore California's ecosystems are important, none are a silver bullet. That being said, forest thinning, adoption of microgrids, and expanded funding to SB 901 all have the capacity to help mitigate the risks that wildfires pose. These strategies will require collective effort and cohesive problem-solving from all levels of government. As we maneuver through these challenges to adapt to California's changing fire regime, it is of utmost importance to remember what is driving these efforts in the first place. That is, the protection of our California ecosystems and communities.